Assalamu alaikum dear students. Today's our topic is addition of two matrices. In the previous video we have discussed how we can calculate the addition of rows and columns individually of a matrix. There we have discussed minutely the logic behind the addition of rows, individual rows and columns in a 2D matrix. And in today's video, we are going to see how the addition of two matrices takes place using a third matrix. That means input is two matrices and the output is the addition of those two matrices, corresponding elements, addition of corresponding elements of those matrices. That will be discussed in today's video. So our video is program to add two matrices. First of all, as usual, we have to include the header files conio.h, iostring.h, as we are going to use the scanf, printf, getch, and clearskin functions in the program. So it is mandatory for us to include those header files at the top of the program. Hash include studio.h, hash include conio.h, while man and a of 2, 3, comma b of 2, 3, comma c of 2, 3, I, j. Here I have declared three arrays of that integer. First one is the first matrix, that means first two-dimensional array consisting of 2 rows and 3 columns. Second one, 2 rows and 3 columns, and third one, C array by name C, 2 rows and 3 columns. In this video, in this program, the addition of these two arrays, these two matrices, matrices A and matrices B, will get stored in the matrices C. For example, here we have, this is A, 1, 2, 5, 6, 7, 8. This is matrices A, and second one is 8, 5, 4, 6, 2, 0, and this is matrices B. This is A and this is B. And I have declared another matrices, say matrices C, where the addition of these two matrices will get stored. This matrix C is to store the addition of it. That means 8 plus 1, 9 will get here. 5 plus 2, 7 will get here. 4 plus 5, 9 will get stored here. So, first of all, in order to input array, I hope you are familiar for reading the array, how to read the array, how to input the element using scanf function. We have discussed it in last videos as well. So I think no need to discuss here. Still I will insert. For I equal to 0, I less than 2, I plus plus. For j equal to 0, j less than 3, j plus plus. Second, percentage address of a of I, a of j, a of I, a of j. For I equal to 0, I less than 2, I plus plus, for j equal to 0, j less than 3, j plus plus, second percentage address of b of I, j. These two for loops are for reading the elements for array for matrices A and matrices B. I think no need to discuss this working as we have already explained how to insert the elements, how to enter the elements, how to input the elements, how to read the elements in the two-dimensional array. We have discussed it in previous video repeatedly. So I think no need of discuss this again here. So I assume that these are the elements 1, 2, 5, 6, 7, 8, 8, 5, 4, 6, 2, 0. These are the elements of the matrices A and these are the elements of the matrices B. Now what we have to do, we have to write the logic, we have to write the program here for addition of two matrices. How these two matrices get added? Using the third matrix, that is matrices C. Take care. First of all, here I have declared C matrix 2, 3. That means it has 3 values. That means the output must be 8 plus 1, 9, 5 plus 2, 7, 4 plus 5, 9, 6 plus 6, 12, 2 plus 7, 9, and 0 plus 8, 8. This must be output. The addition of these two array must be this. After adding these, we must have this output. How to generate this? What is the logic? Let us write the logic for this. Let us write a program for this. So, I think no need to explain these for loops as we have already discussed in the previous videos, how to read the array, how to input the elements in the array. Now, I am going to write this. Here, the printf continue program addition of two matrices is for I equal to 0, I less than 2, I plus plus, for j equal to 0, j less than 3, j plus plus, C of I j A of I j equal plus B of I j. Printf %d/t C of I j. printf/n get ch and close. See, I equal to 0, I is 0. This is the 0th index, first index, and second index. This is the 0th row and first row. This is the 0th row, first row. 0th column, first column, and second column. 0th index of the 0th row, first row. 0th row, first row, and second row. Okay, take care. This is our output screen, for example. This is our output screen. What will get? We output. For I equal to 0, I have been initialized. First of all, we are going to initialize the I equal to 0. I less than 2. Condition. Is I less than 2? Yes. I, that means 0 is less than 2. That means this condition is true. Whenever this condition is true, the control will enter into the inner loop. Here, for loop. For j equal to 0, j is again initialized with 0. First value. J less than 3. J less than 3. 0 is less than 3. Yes, condition is true. Because 0 is less than 3. The control will enter into the body of the inner loop. What will happen here? A of ij. That means A of, this is A matrix, ij. I is 0, j is 0. That means 0, 0th index. That means this index. Because it has a 0, 0 index. It has a 0, 1 index. It has a 0, 2 index. It has a 1, 0 index. It has a 1, 1 index. And it has a 1, 2 index. Similarly, this first has 0, 0 index. That means 0 row and 0 column. 0 row and first column. 0 row and second column. That means 0, 2. This one, this has first row. This is the first row. First row and 0 column, 1, 0. It has first row and first column, 1, 1. And this has one first row and second column. Same as this. And similarly, this first has a 0th row and 0 column. 0th row and first column, 0th row and second column. This has first row and 0 column, first row and first column, and first row and second column. Okay, these are the indexes. Let's see. C equal, that means here, A of ij, I is 0, j is 0. That is A, ij, that is 1. The value which is stored at the location ij, 0 and 0th index. The value stored at 0th index. I where I is 0, j is 0. That is this 0, 0. That is 1. That is to be going to be added with the value b of ij, this b, this is the b, ij. I is 0, j is 0, 8. That means 1 plus 8. This index was 0, 0 index, that is 1. And at index 0, 0 of matrix B, that is A. 0, 1 plus 8, that will become 9. 1 plus 8 will become 9. That will be assigned to this C of ij. That will get assigned to C of ij. C of ij, this is the C, where we are going to store the result. Where we are going to store the result. C of ij, that is 0th index. This is 0th index, 0, 0, 0, 1, and 0, 2. Similarly, this is 0, 0, first one. Now this is 0 and 1. Here it is 1, 0, 1, 1, and 1, 2. Take care. That will get stored at C of ij. C of I is 0, j, that is 0th index. What? 9. 9 will get stored here. Okay. Printf percentage C of I, that will get printed here. And control will go to j plus plus. J will become 1. Again, the condition will get checked. J less than 3, yes. 1 is less than 3, condition is true. Then A of ij means 0 to 1. The element which is present at the index is 0, 1. Where is 0, 1? This is 0, 1. That is 2. 2 plus B of ij. B. This is a B matrices. Index is 0, 1. 0, 1. That means 5. 5 plus 2. That is 7. 7. That is 7. 5 plus 2 is equal to 7. That will assign to where? C of ij. C of ij. That means 0, 1. This is a 0, 1 location. Here. Here it will get printed 7. Okay. Again, j plus plus. J will become 2. Condition will get checked. J less than 3. 2 less than 3. Yes, condition is true. Whenever condition is true, the control will enter into the body. Here, what is in the body? A of ij, that means 0, 2. The element which is present at the index is 0, 2. 0, 2. This 5. Plus B of ij. Here, I 0, 2. Here, 0, 2. This element 4. They will get added. 4 plus 5 equal to 9. And that will be assigned to C of ij. C of ij means 0, 2. That is 0 here. 4 plus 5 is equal to 9. 9 will get stored here. Okay. J plus plus. J will become 3. Condition will get checked. J less than 3. Is 3 less than 3? No. Condition is false. Whenever this condition is false, the control will not enter into the body. Then where will control go? Control will go outside the body of the inner loop. Because the body is inner loop is from this brace to this brace. The control will go outside the body of the inner loop. That means here. Printf selection. Here the selection takes the cursor to the next line. That means here. Cursor will reach here. Again, it will go to the outer loop. Okay? Because outer loop is still existing. Here I plus plus. I was 0, it will become 1. Take care. It will become 1. Cancel will get checked. I less than 2 is 1. 1 less than 2? Yes, cancel is true. When the cancel is true, the control will enter into the body of the first loop. That is this. Second. J0. J equal to 0. Assign the value J to 0. Next. J is going to be initialized now 0. Again here. J less than 3. 0 is less than 3. Yes, cancel is true. It will enter into the body. A of ij, that means 1, 3. A of ij. This is A array. This is A matrices. Index, the element which is present at the index 1, 0. What is 1, 0? Here. 1, 0. That means 6. Plus B of ij. Here. B of ij. Ij means the element which is present at index 1, 0 in the matrices B. That means 1, 0. Where is 1, 0? Here is 1, 0. 6. 6 plus 6, it will become 12. 12, that will get assigned to C of ij. That means the index 1, 0. Where is 1, 0? Here. 12 will get stored here. And again, J plus plus. J will get plus plus. J was 0, it will become 1. It will become 1. Again, the cancel will get checked. J less than 3. Yes, 1 is less than 3. 1 is less than 3. The cancel evaluate is true. Whenever the cancel evaluate is true, the control will enter into the loop. A of ij, that is 1, 1. The element which is present at the location at the index 1, 1 in array matrices A. In matrices A. This is matrix A. 1, 1. This is location index 1. What is the element here? The value here is 7. Plus B of ij. That means the element which is located at index 1, 1. Here is 1, 1. Their element is 9. That will get added to this one. What will become? 9 plus 7. It is 16. 16. And that will get assigned to C of ij. Ij means here, the location which is present at 1, 1. C of ij. C of ij means here. 16. 16 will get stored here. And again, J plus plus. J was 1, it will become 2. Again, the cancel will get checked. J less than 3. Yes. 2 is less than 3. The cancel is true. Here, control will enter here. C of ij equal to A of ij. A of ij. That means I is 1, J is 2. That the element which is present at index 1, 2. Where is 1, 2? Here. 1, 2, 8. Then plus B of ij. The element which is located at index 1, 2 in matrix B. That is this one, 0. That will become 8. 8 plus 0 equals 0. That will get assigned to C of ij. That means that will get assigned at the location, that will get stored at the location 1, 2. This is this location. 8. 8 will get stored here. Okay? Print that percentage C of ij and that will get printed. Here, and again the control will go here. J plus plus. J will become 3. J less than 3. 3 is less than 3. No. The condition is false. When the condition is false, the control will go outside the body of this loop and it will reach here. The control will reach here. Printf selection. Here. Cursor will reach here. Again, it will go to outer loop. I plus plus. 2. Condition will be I less than 2. Is 2 less than 2? No. 2 is not less than 2. That means this condition is false. Whenever this condition is false, the control will not enter into this loop. The control will go outside the body of the loop here. That's it. Control will be here. And up to that point, the addition of two numbers will have been printed. Will have 9, 7, 9, 12, 16 and 8. That we want. 9, 7, 9, 12, 9 and 8. Where is 16 here? 9 plus 7 equal to, 7 plus 9. I don't. 7 plus 9 will get here printed. This is the array that we want to store. This is the output that we want to store. So I hope that you have understood the logic behind how the memory math, by using the memory math, how the matrices, two matrices get added. How can we add the two matrices in C? So we have to take care of one thing where we are going to add two matrices. Then the dimensions should always be same. That it is the array of 2 into 3, and this is also the matrix of 2 into 3. 2 rows and 3 columns. 2 rows and 3 columns, and also the result is also 2 rows and 3 columns. We cannot add the matrix of different dimensions. That means we cannot add the matrix of 2 rows and 3 columns with 3 rows and 2 columns. We cannot add this. The dimension, in addition, it is mandatory that the dimensions of the matrices must be same. They must be of the same dimensions. The number of columns must always be equal to the number of rows, and number of rows must be equal to the number of the columns. If the dimensions are not same, we cannot perform the addition on the matrices. We have to take care of these things. We have to take care of these rules when we are going to add the matrices. Hope you have understood how to add the two matrices using this program. And till next video, take care. Bye bye.